The Real AI Podcast with Michael Hainsworth is brought to you by Microsoft.
It's been said science fiction has influenced the development of the flip phone and tablet, voice-controlled computers, and by 2030, a universal translator?
Okay, I'll be optimistic here. I say by the end of the decade, so 2030, and if that doesn't happen, you can come back to me and grill me about it.
We talk to our smartphones and speakers all the time. So does being able to translate languages today set the stage for talking to aliens from a galaxy far, far away? Closer to home, the technology is being leveraged to save the endangered language of Canada's Inuit using Microsoft Translator. In this episode of Real AI, I'll introduce you to the man helping bring us closer to a sci-fi future. But first, meet Carleen Ariak, protector of the Inuit language.
The Official Languages Act recognizes the three languages in the territory, and those three languages are English, French, and the Inuit language. And the other legislation is the Inuit Language Protection Act. And what that does is ensures, it's like the title says, that the Inuit language is being protected. So in the Inuit Language Protection Act, it's also laid out that, for example, territorial institutions, the GN department, its public agencies, the private sector, the municipalities, they have to follow the Inuit Language Protection Act and ensure that the Inuit language is being used within their business. So if they're communicating to the public, they have to ensure that they are using the Inuit language, whether it be through communication, verbally, in writing, in advertisements, in news releases, in public service announcements. They have to ensure that they are using the Inuit language.
Inuktitut is spoken by almost 70% of the population, but it is still considered an endangered language?
In the Inuit language, we have Inuktitut, which recognizes the Inuktitut language, and Inuit. So Inuktitut is mainly spoken throughout Nunavut. Inuit is spoken mainly in the Kitilneyut region of the communities, especially in Cambridge Bay and Polokdo. So the Inuit language in Inuktitut recognizes the two dialects. Inuktitut is a lot stronger because it's spoken throughout more people within the territory. And Inuit has been considered an endangered language.
So with these primary dialects, what does it mean to have Inuktitut, the dialect, introduced to Microsoft Translator?
So I've always been curious and welcome new technologies, new resources, new tools that can help strengthen our language. Not only strengthen the use of our language, but also to encourage people to use it more, to encourage people to learn more, and to have more resources available so that people have it literally in the tips of their fingers. So this new tool makes that available to more people to encourage the use, the learning of our language.
Is there a word in your language for artificial intelligence?
Our language is, and in order for a language to survive, it needs to consistently grow and come up with new terms. Traditionally, there was no word for a computer, for example. There was no word for the internet. But through innovation, through working together, through brainstorming with different people, elders, new users, these words have been created. So for the word computer, derives from the word brain. The word for internet, is a derivative of what shamans used to practice. So physically, when shamans went through their practice, their physical being was in one location, but their spirit was traveling to other places. So when we're on the internet, we're physically in one location, but we're able to travel anywhere. So that's where the term ikiakijut comes from. We're still not quite there yet, I don't think, with the term artificial intelligence, but I won't be surprised if it comes up soon. And we do have an organization that its job is to come up with new terminology. So I'd be interested from not too long from now, I suppose, if a new term is created.
And it sounds like when you're creating these terms within your culture, it's all very poetic.
Our language is beautiful. I would encourage everyone and anyone to learn it. And we've had to be creative, innovative. We've had to be working together and brainstorm in ways that our language can be strengthened, be revived, be used, be learned. And so we have to be creative in order for our language to thrive. I've always said if a language does not change or evolve, it's a dead language. So our language needs to evolve, it needs to create, it needs to adjust in order for it to survive with the times.
So you've tested Microsoft Translator. Describe your initial reaction to the very first time you experienced artificial intelligence in action.
Well, I was curious. I was certainly curious. So I tried it out right away. And I've tested it with colleagues as well. And the first time I tried it, it was a little, I don't know what the term is. It needed some corrections. But as I went through different terms, sentences, it was accurate in some cases. And it's a great first step for people to use. Mind you, at this point, I would probably encourage pair of eyes to see if there's any corrections. But the longer we're using this, the longer it's being used, the more rich it will be, the more usable it will be. But I think it's a great first step for people to use.
That is really one of the remarkable things about machine learning is it's a machine that's learning. And to your point, the more it's used, the more we give it feedback, the better it's going to get. How do we use this technology to bring people together?
It could be used, as I mentioned earlier, the Inuit Language Protection Act is there to ensure that the private sector, for example, if they want to do an advertisement, they have to advertise in the Inuit language. So this tool, for example, could be used as a starting point for the private sector to translate their advertisements so that they can bring in more customers. This tool can be used to ensure that more people are communicating in the Inuit language, to encourage the learning of experts, elders, to first-time learners. It can encourage dialogue so that our language is in effect being spoken more.
It sounds like this is really a great first step for the private sector, and the more you can get the private sector on board, not just with the language, but with complying with the law, the greater the culture grows, the greater the economy grows, the greater the community grows.
We've always encouraged, and that's what our role is. As the Languages Commissioner, I have to ensure that the private sector complies with the legislation. We want to encourage that, and the more tools that there are available for the private sector, the better. It's also, it could be used by first-time learners. It could be anyone from someone who wants to learn the language. It could be youth. And you know what, with the technology, you don't necessarily have to be in Nunavut to learn. You can be anywhere because this tool is available not only in Nunavut, but all over.
So the private sector, it sounds like it needs help in bridging the language barrier and complying with the law.
Yeah, and the private sector, as well as the government of Nunavut, its public agencies, the federal government, municipalities, they all have a role to play in complying with the Inuit Language Protection Act. And so this tool is a way for, as a first step, to encourage those that need to comply to use this tool to comply with the law.
You mentioned a lot of different types of individuals and groups that would benefit from using this technology. Give me an example, though, of an opportunity AI and language translation provide for remote communication and connectedness.
If we were going to provide something to the public, if we're going to make an announcement, for example, to the public, and I'm not available to translate, we can use this in our office as a first step to translate either a document or a short document, an advertisement, and use it in that way. Others can also use it. The schools are teaching the Inuit language. So youth who want to learn more about the Inuit language, they can use this tool. And in particular, I must say this is in Inuktitut. Not quite available yet in Inuit, but in Inuktitut. So it could be used by anyone and everyone. And that's the thing about this new tool.
We know that when immigrants come from outside of Canada that speak a different language than the two primary languages in this country, that often it is a family's critical priority to ensure that the young people that they're raising in their household retain the language of their homeland. Tell me about this, though, for Nunavut residents. Are young Nunavut residents more or less likely to be speaking their native language? And do we need to ensure that they use this kind of technology to keep them in the loop?
Yeah, so with language retention, with the strength of our language, yes, it starts at home. Yes, it's important to teach our kids at home. I can use myself as an example. When I was growing up, English was not my first language. Inuktitut was. It wasn't until mid-elementary that I learned English. And the curve was so quick that my parents witnessed that they started instilling, for example, all Inuktitut speaking days or all Inuktitut speaking events, so that my parents realized the more I learned English, the more I used it. I used it with friends at school. And then when I come home, that would continue. But in order also for our language to strengthen, we also need that available everywhere. So it starts at home, but it also needs to be supported in the schools, with the government services, with the private sector. And there's been studies, for one, Statistics Canada did a study on this, and there is a decline in the use of our languages. But that's why it's so important to not only encourage our children, but also encourage each other to use our language more in all facets. And with any tools that we have available, through interaction with each other, through interaction with children, elders, knowledge keepers, we need to all work together to ensure that our language survives and is strengthened.
So how does it all work? We know machine learning relies on big data for big results, but few people speak Inuktitut. Microsoft principal data scientist Christian Fetterman says 40,000 speakers was enough to build an effective translation tool.
I mean, it's still not much, but it's somewhat alive and kicking. But then for, say, Western Canada, BC, for some of the Haida languages, we talk about 5 people still being fluent in that language, and then we are really on the far long tail, where we might want to preserve, but maybe it's already too late.
How does the number of people speaking any given language impact artificial intelligence in its ability to essentially create that necessary translation capability? We know that AI is all about big data. Where does the big data come from in a language that needs protection?
Hopefully from previously archived and recorded materials, which potentially exist in the form of books and dictionaries, which now can be digitized. So if that exists, if 100 years ago we still had maybe a couple of thousand native speakers and they collaborated typically with a university or some academic researchers, they might have produced scriptures which contain an encoded version of their language. And then we would look into digitizing that and making it accessible. Possibly and hopefully communicating with the existing native speakers in order to make sure we do it right. If this doesn't exist, then one of the, I think, last frontiers of not necessarily AI, but also of linguistics is to talk to these people and typically create recordings of these conversations to preserve at least the spoken language and then try to somehow go about creating this encoding into some digital form the machine can understand. But then, as you said, AI and machine translation in particular is based on vast amounts of parallel data, which means if we only have a handful of sentences or a handful of hours of conversation, then it is highly unlikely that we can build great translation models. It's equally unlikely that we can build great speech recognition models.
Speech recognition is part of one of the 5 components of Microsoft Translator, is it not?
Yes. So behind the scenes, the speech team and translator team report up through the same boss, and one of our components is spoken language translation or speech translation, and there we partner with the speech team to make sure that for new languages, hopefully after we ship them for translation, we also get them out for speech recognition. Now the difference here is the data is different, so we need your proverbial phone book full of English text and full of the corresponding French translation to learn to train a translation model from English into French and vice versa. The speech guys do need these recordings of Canadian French and the corresponding transcript. So that's a different style of training data. But then behind the scenes, the actual training technology, which these days is called or based on neural networks, is surprisingly similar. And yes, this comes from the same team here at Microsoft. And one of the interesting questions will be if we can challenge, or if we can get our speech friends to hopefully at some point also add speech recognition support for Inuktitut.
You mentioned neural networks. This is not just Star Trek technology. We're actually using that kind of next generation computing for translation?
Yes, like we now all use these nice data tablets and slabs we used to see only in the next generation. We also now adopted this notion of the universal translator a bit more. We're edging closer to it, so it's not that you can just speak and some magic voice will give you translations for everything. But these days, if you look at Surface earbuds or other products, it's basically what they all integrate now is they connect to your phone. You can speak in your language, or you can hear somebody speak in their language, and then they would translate that into your language, and you would listen into that on your earpiece, right? And that is getting closer to this idea of having the next generation Star Trek features. And the neural networks are a big part of that. So in terms of technology, architectures, we in the mid-90s or so, we switched everything to statistical models. So that proved vastly superior to the previous style, which was rule-based, where a human, say, encoded that a specific sequence of English words or English word classes should be translated into a specific other sequence of French word classes. And then everything turned statistical, which had a big advantage, namely that you could suddenly let loose the computer on large amounts of data, which then taught it a lot of things otherwise it could not have learned. And then in the mid-2000 like 2010, a little afterwards, what happened is we reached the next step on that ladder, which brought back this age-old technology of so-called neural networks. So the earliest neural networks, the perceptron algorithm, that is technology which basically goes back decades. It was just that the respective computing machinery was not powerful enough to really leverage the inherent learning capability of these algorithms. And then enter GPUs, these nice computer graphic processing units, which everybody used to play video games in the early 90s. They turn out to be super powerful computers for very specific purposes. And one of their main purposes is basically running a gazillion of computations on vectors of numbers and matrices of numbers. And interestingly and quite fittingly, we exactly use these vectors and these matrices full of number sets to encode the state of neural networks. So somehow this gamer hardware then happened to become the new hardware we would need to run, or we could use to run machine learning at a much bigger scale and much more effectively. And that resulted in translation quality and or also speech recognition quality to go up super drastically. So that was a coincidence which played out very nicely in our favor. It was bad for the gamers because now suddenly all these GPUs are much less available and also much more expensive. So sorry about that.
Yeah, the kids can't get their video games in high quality because you guys are too busy using them for artificial intelligence. It was fascinating to me to learn that traditional CPUs in a computer, they can be super fast, but the analogy of a highway is that they're super fast speed limits, but only a few lanes, whereas GPUs in the graphics processing units, they're slower speed limits, but there are so many more lanes, so many more cars can get to their destination. And of course, those cars being all of the data bits that you're trying to incorporate. But the idea that grammar is driven by rules, but AI-based translation is driven by data is something that has been known for a little while now. You've said, though, that we're not really at the point where AI seriously considers grammar. How do we ensure that when we use a Microsoft Translator component in the far north for Inuit, that we're actually getting comprehensible translations?
Okay, let's decode that question and unpack it a little bit. So the first bit is grammar rules and machines maybe not adhering to those. So I think grammar rules are something which makes very explicit the structure and the nature of a specific language. So if you have a linguist for some language pair and this linguist introspects that language and really spends a lot of thought on how that language is structured, how the transfer from language A to B functions, then that can result in rules. So these are very explicit constructs which encode that mapping from source to target language. Now, when we look at data, we don't have that explicit mapping, so that is true. We don't tell the model, look, if you see a specific sequence of these part of speech tokens, and one of them is the subject and one is the direct object, blah, blah, blah. So once we have that, we don't do that. We just don't tell it explicitly, here's a set of rules for the language and here's a vocabulary, now you can translate. Instead, what we give it is large piles of data. Now, these large piles of data, what they represent actually is an implicit encoding of the side effects of all the rules, so to say. So basically what this means is inside this big pile of data, we hope that enough instances of all the relevant rules are available, and then the machine can learn to maybe not understand here's a specific rule, though ultimately at some point that would be nice if we can let loose a neural network on a lot of data and it gives us a high level summary of here's the basic rules for Inuit into Canadian French translation. That would be super fascinating. So I'm not saying that neural networks can never go there, but currently we're just not modeling for these explicit rules. It's just You have an implicit knowledge about the nature of the language inside your data. You focus on cleaning that data so that it becomes less likely that polluted data messes with your translation quality. And then the model can really leverage that data to learn the mapping from source to target language.
So we've talked about neural networks, machine learning systems. How long before we get ubiquitous language translators like we see in science fiction shows like Star Trek and Doctor Who?
Okay, I'll be optimistic here. I say by the end of the decade, so 2030. And if that doesn't happen, you can come back to me and grill me about it.
Christian Federman is a principal data scientist at Microsoft in Seattle. Karleen Ariak is the Inuit Languages Commissioner in Nunavut. While Microsoft Translator for Inuktitut may have a small user base, it provides a big opportunity for artificial intelligence researchers to expand their understanding of effective machine learning tools. And doing all the heavy lifting in the cloud instead of on your smartphone provides for a global base of installed users, constantly helping refine that algorithm as it works. And if Christian's prediction of a universal translator within the next 8 years comes true, we'll be able to seek out new life and new civilizations right here on Earth. I'm Michael Hainsworth. Thanks for joining us.
You've been listening to the Real AI Podcast with Michael Hainsworth. Subscribe today and visit Microsoft.com/AI to see exciting real-world examples of real AI in use today.